Hello everyone, hope you all are doing well. In this video, we'll discuss the last problem of Leetcode Weekly Contest 308. It's a hard level problem. So the problem name is build a matrix with conditions. So you are given a positive integer k. You are also given a couple of 2D integer arrays. The first one is a row conditions array of size n, where each value in that 2D array represents above I, comma below I. We'll see that what that means. And in the second 2D array, column conditions, suppose that is of size m. So each value in that particular column conditions is obviously an array which represents left of I and right of I, right? So the two arrays contains integers 1 to k. So you have to build a k cross k matrix that contains each of the numbers from 1 to k exactly once. The remaining cells should have the value 0. The matrix should also satisfy the following conditions. The number above I should appear in a row that is strictly above the row at which the number below of I appears. Now this is true for all I from 0 to n minus 1. Similarly, the number left of I should appear in a column that is strictly left of the column at which the number right of I appears for all I from 0 to m minus 1. Pretty complex one. We'll see that into the explanation. Just bear with me. Return any matrix that satisfies the following condition. If no answer exists, so just return an empty matrix, right? Let's jump to the explanation. So the problem says that I'll take the first example, k equals to 3, and we have row conditions, certain row conditions. This is a 2D integer array, right? So suppose this is the first value and suppose this is the second value. Also a column condition 2D array is given. So this is the first value and this is the second value, right? Now what does this mean? Suppose I pick this value 1 comma 2. This is for row conditions. So this says that the row which has value 1, suppose that is row 1, and suppose the row which has value 2, suppose that is row 2. So row 1 has to be less than row 2. That means the row which will have the first value should be above the row which has the second value. This is what it means. Let's take the second one, 3 comma 2. It means that the row having value 3 needs to be above the row which has value 2. This is what the row conditions means. Now similarly, let's come to the column condition. So the first value is 2 comma 1. It says the column having value 2 needs to be on the left side of the column which has value 1, right? Similarly, 3 comma 2. So the column having value 3 needs to be on the left hand side of the column which has value 2. Like this is my matrix. Suppose there are certain rows, columns, I don't know about that, but this value 3 needs to be on the left hand side. Suppose it is here. So the value 2 will be present somewhat here, right? Somewhat here, any place here, but it needs to be in a column which is on the right hand side of the current column where 3 is present. So this is what column and row conditions mean, right? So this is what the problem is saying. Now what we need to do? We need to build a k cross k matrix, right, which satisfies these conditions given in RC and CC, or row conditions and column conditions, and each value can obviously be used once. That means 1 to k needs to be present in a matrix only once, and the rest of the values will have 0. This is what the problem is saying, right? And it needs to satisfy these conditions. Now if you have seen similar type of problem, or if you are seeing this problem for the first time, so just analyze this problem. This problem is having certain conditions, right? This problem is having certain conditions. Which type of conditions? Like if I consider 1 comma 2, so it says that 1 is having a dependency on 2, or other way around, but suppose I take 1 is having a dependency on 2. That means 1 needs to be on the left hand side of 2, right? If I take the second one, so 3 2, 3 needs to be on the left hand side of 2, right? Similarly, if I consider column condition, so 2 needs to be on the left side of 1, and 3 needs to be on the left hand side of 2. These are certain conditions, right? And we need to find the order, that how we place these numbers so that these conditions are satisfied. So some conditions are given. Let me write it down. Some conditions are given. Find order, and we need to find the order so that these conditions are satisfied. So a typical topological sort problem. right? It can be solved using a queue as well, a similar concept, but I'm just telling. And for this we have an algorithm, Kahn's algorithm. If you are hearing these things for the first time, no worries, we'll go into that logic. But yeah, having some knowledge of these things will be really helpful, right? Obviously there will be some first time that you will be seeing these things like there will be some or the other time you will be seeing it for the first time, right? After that you have solved a couple of problems based on this, you'll be good to go, right? So yeah, these will be the things. Now what is the first step that we'll do? So as we saw, this is a graph, these are certain conditions. So what we'll do, we will form the adjacency list of this graph. Right now just consider row conditions, forget about column conditions, because these are two different problems, sub problems of this major problem, right? Construct the adjacency list. Also construct the in degree of every node. What is in degree? So suppose I have a node x, I have a node y, right? So there is an edge going from x to y. So here in degree of y will increment by 1. In degree tells that how many edges are coming to this particular node, right? So here in degree of y will be 4. What will be the in degree of x? It will be 0, right? No edges coming here, right? So what you will do, how you will construct the adjacency list? So I have suppose 1 comma 2 and I have 3 comma 2, right? So just traverse this, and what you do, what is the adjacency list? One is having 2 as one is pointing to 2, right, based on this condition. 3 is pointing to 2 based on this condition. Also while computing the adjacency list, also calculate the in degree. So how you can calculate the in degree? For this, in degree of 2 will be incremented. For this also, in degree of 2 will be incremented, right? Because the edges are converging at 2. Coincidentally, it is the same value. Suppose a value would have been, or consider generic values x comma y. So x will have y in the adjacency list. Also in degree of y will be incremented by 1, right? This is the major thing that you will do, right? Now just see what is in degree here. So suppose there is a node x with in degree equals to 0. Suppose there is a node. So what does this mean? This means that there is no incoming edge from any node, or there is no incoming edge to x, right? So that means this node is free to be placed anywhere, right? If this is my matrix, right? So this says that I am not dependent on anything, right? I am not dependent on anything. That means there is no node, there is no value on the left side of me, right? So place me anywhere. Just consider about rows, forget about columns. So suppose I place it here, I place x here, right? Now what will happen? There must be some nodes which must be having in degree, like suppose this is, right? X had an in degree of 0, but x was having some edges from x to y or x to z, right? Now what you do, decrement the in degree of the neighbors of x. So first pick a node having in degree 0, process it. I'll tell you what process means, and then decrement the in degree of the neighbors, because now what happened, y was dependent on x, right? Y was dependent on x. Now what happened, x has a fixed value, like you have processed x. So now y is not dependent on any node which is still to be processed, right? So decrement the in degree of y and decrement the in degree of z, right? Now suppose in degree of y or z, that also becomes 0. So you start processing that as well. How do you process it? Take a queue. So once you build the adjacency list, push all the values with in degree equals to 0 in the queue, right? And then what you do, when you start pulling data from queue, do this thing. That suppose you have pulled a value x. So what you do, you traverse the neighbors of x and decrement their in degree by 1, right? Decrement their in degree by 1, because there were edges from x to y, x to z, and so on, right? And then what you do, you keep on doing this, right? Now what does processing means here? As soon as you pull a node x out from this queue, so now what will happen, take an extra array, let's call it row. I'll explain what row is. It will become more clear when we move to the code, right? Suppose, so now you have pulled out this node. So row of x Where should I place X node? Where should I place? This is the first node, right? So take a variable count. Initially it is 0. So make it equal to this. Increment count. What does this mean? This means that if I talk about the order of the rows, then the node X, the node next had the order 0. This is the first node that is being processed. So you can place it in row number 0. Let's come to the second node. Suppose I pull another node from the queue. Then row of Y will become in the next iteration equals to count, the current value of count. And again you increment count plus plus. The value of count will keep on incremented because we are running these things in a loop, right? While queue is not empty, right? We'll see that into the code, right? Now what will happen? Suppose you come out of the loop, and if count equals k, what does this mean? This means you have processed all the k nodes, all the k values. Then we are good to go. We move to process column conditions. Exactly similarly how we process row condition, we process it. Otherwise, if count is not equal to k, that means you have not processed all the nodes, and hence you return an empty matrix, because this is not a valid condition, right? This is not a valid condition. So this is how you will approach this problem. Let's come to the last part, and then I'll just reiterate the whole problem, the whole solution, because I know there are multiple steps, and someone who is not familiar with these in degree concepts will be a little bit confused, right? So now the last part here will be, then you start traversing. You have done the 95% of the things are done. For all the k values, just see where you need to place it, right? So these are the k values. Now where you will place it? Suppose answer is my array. So row of I, right? I am considering this node. Nodes can have value or numbers 1 to k. So where will I place it? Equals to I. What does this mean? So row of I, this is what I was talking about, was calculated when I was processing row conditions. Column of I will be calculated when I will be processing the column conditions, right? Now what happens? Suppose I consider the value 1. So where will the value 1 be placed? It will be placed at row of I. What is row of I? It is row of 1. So here we saw that row of 1 will contain that what was the order of processing of ith node, right? So row of 1 will contain a value, let's call it x. Similarly, column of 1 will also contain a value, let's call it y, right? So these two things will tell me that suppose the order of this one was let's say that, okay, you place the node number 1, you place value 1 in the 0th row. This was confirmed. But when I was processing the column condition, it was said that, like, I'll not place it here, but I was just telling, this said that, okay, place the row number, to place value 1 in row number 0, but the column should be the third column, right? So this will tell me 0, 1, 2 is the row, 0, 1, 2, 3 is the column. So I place 1 here. So this is how it is helpful, right? Suppose I talk about row number 2. So suppose I talk about value number 2. So suppose row of 2 was 1. That means place it in the first row. And suppose the column was again 2. Right? So place it here. 1, 2. So 1, 2. Place the value here. So this is how it is useful, right? So let me just reiterate so that it becomes more clear, and I'll also move to the code, right? So there were certain conditions given in the problem, like 1 is dependent on 2 and so on. Now what happened? Based on these conditions, we found out that this represents a graph, and this graph has certain conditions, and based on these conditions we need to find the order, that in which way should I place the values from 1 to k, right? So that is why we move to topological sorting or Kahn's algorithm or the in degree concept, right? Now what we do, we constructed the adjacency list, right? So the adjacency list was constructed here, and while I was constructing it, I was also calculating the in degree of every node, right? Now what I did, after these things were done, I saw that in the first iteration, I saw that which all values have an in degree of 0, because that means let's process those values first, because those values do not have a dependency on other values, right? So start processing it. How do you process it? Take a queue, push the values, sort of BFS, right? Breadth first search. Push those values in a queue, start processing it. Now when you process a node, what you do, you decrement the in degree value of the adjacent nodes, because suppose value y was dependent on 2 nodes, right, A and B. Now A has been processed, so it is dependent only on one node now, right? So that is why we decrement the in degree. And as soon as the in degree of y becomes 0, you process this as well. Now what does process means? Process means that in which order am I traversing the nodes. If I talk about the rows, right? So initially I have row number 0. So what I did, for the current node, the row will be 0, and for the next node the row will be 1, and so on, right? This is how I process in the first phase. I do the exactly same things for the column as well. When I am done, I get the relative order, I get the exact placements of all the elements in the form of row and column, and I just put that into my answer and I just return it, right? So this is the solution. Let's come to the code part. Yeah, so this is one of the C++ codes that I was looking through, and I found it to be very useful, hence I'm showing this in my video. So yeah, if you see here, again on line number 3, 4 and 5, so in degree is something that I was telling you about, and line number 4 and 5, so line number 4 is basically taking care of the what do you call it, the adjacency list. Here you could have taken a map here as well. I was just a bit lazy to write the same thing in Java. That was the main thing. And then you have row and column. So on line number 8 you can see I have my answer array. I have my answer. On line number 7 I have a queue. So on line number 9 you can see I am building the adjacency list for row conditions, and I'm also incrementing the in degree, right? In degree on line number 11. Now what I do on line number 13 and 14, after the in degree for row conditions is calculated, I see which in degree is 0, for which node the in degree is 0. Just push that node into the queue, right? Then on line number 16 I have count equals to 0. This will basically tell me that what is the order of the numbers that you are processing for row condition. So while queue is not empty, what you do, you fetch the node in the front, and then you assign it a particular value based on count, and then for all the neighbors just decrement the in degree of those neighbors, right? Whatever I have told you in the solution, right? Now you come out of the loop. On line number 25 you just see that if count is not equal to k, that means you have not processed all the things. That what you do, you return an empty array, right? You return an empty vector because you are not able to process it. Else row conditions are valid, move to the column conditions. For that you need to construct another adjacency list for column conditions. So that is why on line number 27 we have cleared it. We could have avoided it as well, but yeah, this was one of the implementations. Then again we construct the adjacency list, we see what is the in degree, we again run a queue loop from line number 37 to 44, and when all these things are done, we again come to line number 46. If count is not equal to k, just return an empty matrix, right? Count was reset on line number 36. Else the last thing that I was telling, that for each value from 1 to k, just see where we need to place it. So how I will know that condition? That condition will be rows of I and columns of I. I've already assigned values in rows of I and columns of I, so I'll assign the ith value to that index, and then we are good to go. So if I just submit this solution, so yeah, it will be accepted and we are good to go. I'll share this solution as well. I'll add the link of this solution in the comments. So yeah, hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel, and also in case you have any queries, then do mention that into the comments. I'll be more than happy to revert on each one of them. Thank you. Take care. Bye bye.